Good evening. In tonight's lesson, you will learn how to represent a function using a graph. Let's look at a few how-tos. So in order to represent a function as a graph, the first thing you need to make sure is that your function is already solved for y. And then you need to find 4 solutions. If it helps you, make a table of values. The next is to plot the points on the coordinate plane, and then connect your dots to form a line. Now all of the functions that we're going to be working with today are linear functions, so they should all form a line whenever you plot them. So let's look at our first example. We're given this function, it's already solved for y equals x plus 4. Well, now since we're graphing, hey, look at our coordinate plane and let's see what kind of values I want to pick for x. Because remember, we can pick anything we want for x, but we don't have a very large coordinate plane, so we want to be kind of picky about the numbers that we pick. So I'm thinking that we just pick some pretty easy values. So let's just pick -1, 0, 1, and 2 for our values. Okay, and then this is going to be my function here. So I have x plus 4 that I'm plugging this into. So now, just like we learned yesterday, all we have to do is plug our function in. Okay? So I'm going to plug in -1 for x, 0 for x, 1 for x, and 2 for x. And then the rest of my function stays the same. Plus 4, plus 4, plus 4, plus 4. So then now I just have to simplify those. So -1 plus 4 is 3. 0 plus 4 is 4. And then 1 plus 4 is 5. And then 2 plus 4 is 6. And if you remember from yesterday, our final column here is our ordered pairs column, because this is what we need to graph. So the ordered pair -1, 3, 0, 4, 1, 5, and 2, 6. So then what we do from here is we go to our graph and we graph those points. So remember, this is our x-axis and this is our y-axis. So I'm going -1, 3. So I go to the left 1 for negative and then up 3 and put my point. 0, 4, which means I stay, and I go up 4, plot my point. 1, 5, I go to the right 1, and then up 5. And then 2, 6, to the right 2, and up 6. And if at any point in time one of your dots doesn't line up, that means you did something wrong when you plug them into your function. Because like I said, these are all linear functions, which means they all should form a line. Okay, let's move down to our second example. So I'm looking at this one. If you remember from yesterday, what I said is that when I'm putting it into my table for my function, I always want to write my x first. It just makes things a little bit easier. So I want to write -2x plus 3. They are equivalent. They're the same. They just look a little bit different. Okay? So the same values that I want to use, -1, 0, 1, and 2. And I plug those in. So -2 times 1 plus 3. -2 times 0 plus 3. We have -2 times 1 plus 3. And we have -2 times 2 plus 3. And notice all the red, those are my input values. And those are the values that I'm plugging in to my function. So now that I just solved them, -2 times -1 is 2, plus 3 is 5. -2 and 0 is 0, plus 3 is 3. -2 and 1 is -2, plus 3 is 1. And -2 and 2 is -4, plus 1 is plus 3 is -1. So then I have my ordered pairs, and so I need to plot those points now. So for my first ordered pair, I have -1, 5. So once again, I have x and y. So I'm going to go left 1 and up 5. And then I have 0, 3. So I have stay, and I go up 3. And then I have 1, 1. So I go over 1 and up 1. And then I have 2, -1, so over 2, down 1. And once again, if at any point in time we graph those and we do not have a line, that means we did something wrong in our function part. Okay, what I want you to do, I want you to take a moment and try this problem on your own. Remember, you need to solve for y first. Okay, welcome back. I hope that one wasn't too difficult for you. We will go over those answers in class tomorrow. Let's move on to our third example. So on the back side of your worksheet, we have a new function, x minus y equals 4. It is not solved for y, so I need to do that. So I need to subtract x from both sides to get that y by itself. And now I have negative y equals, and remember we want to write the x first, but it's negative, so negative x plus 4. So I'm still not with y by itself, so I have to get rid of this negative by dividing everything by a negative 1. So y is equal to negative and negative is a positive x. Positive 4 divided by a negative 1 is a negative 4. So that is my function that I'm going to start picking values for. So I'm going to make my table, and I have my x minus 4, and I have my y. Okay, so now I'm going to pick my same typical values. I like to have some on the negatives and some on the positive. It gets a nice well-rounded graph. So when I have my negative 1, I'm going to plug in all those values, negative 1, 0, 1, and 2. And then I just have to subtract 4 from all of them. So I have negative 1 minus 4 is negative 5. 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. So now once again we're going to go to graph. This is our x and this is our y. And negative 1, negative 5, which means I go down this time. So negative 1, 1, 2, 3, 4, 5. 0, negative 4, I stay and then I go down. 1, negative 3 over 1, down 3. And 2, negative 2 over 2, down 2. Once again, I get my nice straight line. And there is our linear function. Okay, now moving on to a different one. So if you look at this problem, one thing should come to your mind. So say that one thing out loud right now. What's different about this problem? All right, most of you probably said, there's the fraction. Okay? It is a little bit different, but we've done a lot with fractions this year, so you shouldn't be too afraid of them. Okay? The only way that this problem changes, and I can still pick anything I want for x. I can pick negative 1, 0, 1, 2, but what you're going to find is if you don't pick good values for x, you're going to end up with fractional answers or decimal answers, and those aren't necessarily the easiest to graph accurately. So when we have fractions, coefficients of our x, we want to pick good values so I don't have any fractional or decimal outputs. So this is already solved for y, so right away I need to make my table. And I have negative 2/3 x plus 1 and a y. Okay? So take a moment and pause this and see if you can think of what good values there are for x. Okay, so the best values we have for x are going to be numbers that are divisible by 3, because I can cross cancel and get rid of that denominator of 3. So sticking with the same way that we've done our other ones, we're going to have one negative coordinate, which is negative 3. 0 is always a good number. 3 is our next multiple of 3, and then 6. So now when I plug these numbers into my function, I'm not going to end up with a fraction answer. So let's do that. So I have negative 2/3 times, and then plus 1. And I'm going to go back in and enter those inputs in just a moment. Because notice, the whole thing stays the same except for our x. So negative 3, 0, 3, and 6. So now I need to simplify these. Well, if I'm multiplying 2/3 by negative 3, I can simply cross-cancel my 3 and my 3, because that's a factor of 1. So then I have negative 2 and negative 1, which gives me a positive 2, plus 1 gives me 3. Here, anything times 0 is 0, so that whole thing goes away, and I'm just left with 1. Once again, I can cancel my 3 and my 3. So I'm just left with negative 2 plus 1, which gives me negative 1. And then our last one, 3 can cancel into 6. So I can go 3 into 6 2 times. So now I have negative 2 times 2, which is negative 4 plus 1, which gives us negative 3. So now here are my ordered pairs. So let's graph them and make sure we get a nice line when we do that to make sure we did this correctly. So when I'm graphing negative 3, 3, this is x, this is y. So over negative 3, up positive 3, 0, 1, 3, negative 1, and 6, negative 3. And as you can tell, we have a nice linear function represented in our graph. So we did something correct. Okay, let's look at our last one. This one, we're not going to have a lot of problems like this, but this is a challenging problem, and you will see this a little bit later in Algebra 1, but I want to introduce you to it a little bit now. So here, if you solve this for y, I need to get that y by itself. So the first thing is we need to subtract 6x from both sides. So now I'm left with 2y equals, and remember we write our x first, negative 6x plus 4. Well now, like in our problem up here, where we had a negative attached to the y, where we divided everything by negative 1, that's similar to this problem, but this time I have a 2 attached. So this time I have to divide everything by 2. And then I get y is equal to negative 6x divided by 2 gives you negative 3x. And then 4 divided by 2 is 2, and that's positive. So then here is my newly solved function. So what I want you to do on your own is go and make a table of values and plot your points to make your linear function on your graph. So the questions you should have done on your own are this last one here, and then the third one on this side. Make sure to write a question for tomorrow, and then we will discuss some problems and do some more practice. Have a good night.